Hello everyone, please write in the chat if you can hear me well and if you can see the presentation. Okay, hello, dear colleagues and listeners of today's webinar. My name is Daria. I am pre-sales engineer in the MES Ethernet switches group. In my capacity, I provide remote testing support for stands, advice on equipment setup, and also assist with troubleshooting any problems and issues that might arise while the switches are in use. Additionally, I conduct webinars. For today's webinar, I would like to discuss the comparison of the basic configuration features between Cisco and LTAC's MES23 line switches. During the presentation, you can ask questions in the chat, and they will be answered either by our moderators or by me at the end of the webinar. So to briefly outline the content of today's webinar, I have divided it into several segments. Initially, we will explore the production of switch lines by LTACs. Subsequently, we will delve into a comparative analysis of configuration between Cisco switches and the LTAC's MES switches. Within this analysis, I will address both basic features, for example, regarding safeguarding clients' connections, along with several aspects related to dynamic routing. To begin with, LTAC's Ethernet switches provide a wide range of products suitable for creating networks with varying levels of complexity. This includes access switches, industrial switches, aggregation, for example, of course, core switches. Based on our product line, there are three main categories: access switches from the MES 14th, 24th, and 34th lines, access and aggregation switches from the MES 23rd line, aggregation switches from the MES23xx line, and data center switches from the 5400xx line. And our third category is pure data center switches, MES 5448 and 7048. The first part of our webinar will focus on configuring the basic functionality of Cisco and LTAC switches. This includes setting up the hostname and time, creating users and privilege levels, creating the VLAN and SVIs, and also we will discuss in detail the configuration of the voice VLAN. Let's start by setting up the hostname and time. As you can see, and this is not only within the context of this specific functionality, but also for future use, the syntax of LTAC's MES is Cisco-like. So if you have ever worked with Cisco switches before, then you will have no problem configuring MES. In this case, the syntax of the commands is virtually the same. However, I would like to point out that the time is configured from the exec configuration mode. And looking ahead, I can say that LTAC switches also support an SNTP client function that allows you to sync time from an external source. Let's now move on to a comparison of user settings and privilege levels. As can be seen from the slide, from our example, there's no difference in the syntax at all. By default, all LTAC switches have the same username and password, which is active until it is manually changed. It is admin. Consider setting up the first, lowest privilege level with the username Jack, and the 15th, the highest privilege level with the password guard mode. In this example, in order to access privilege level 15, you must log in locally as the Jack user, then use the enable command to switch the highest privilege level and enter the appropriate password that you have configured before. On LTAC switches, also you can configure the list of commands that will be available to users with the lowest privilege level from the start. This slide demonstrates how to create a VLAN by specifying its name and associating it with an interface in access mode. To create a VLAN on the OTX MES switch, the VLAN command is used, in our case with the name and, for example, with the number of our VLAN. This command can be executed either from the VLAN database configuration mode or from the global configuration mode as well. By default, all OTX MES switch interfaces are set to access mode in VLAN first. Therefore, you can either run the command to change the interface mode or just immediately specify the VLAN that you want to be in access mode on the interface with this command. Let's move on to discussing the mode of operation for tag traffic on an interface. On switches of the OTX line, several modes are designed to work with tag traffic of a specific VLAN. These are trunk and general modes. The general mode performs the same function as the trunk mode. A distinctive feature of this mode is the ability to remove the outer tag from several VLANs at the output of the interface. It is usually used in conjunction with selective Q&Q, map-mac, voice VLAN, and etc., which allow you to add several different tags at the input. Let's take a look at an example of an interface configuration in trunk mode. As you can see, the syntax is just the same, but additionally, we have our two commands with the all option for the OTX MES. The option add all will add all currently created VLANs to the VLAN database in trunk mode for the interface, while the all command will add not only already created VLANs, but also all future VLANs that will be created to the port in the trunk mode. In this slide, we will discuss how to bind an IP address to a physical interface and a VLAN. For a physical interface, you can register an IP address directly on the OTX MES switch by specifying an address with the mask that suits your needs. For example, you can use the mask both slash and both bit format. If you create an SVI on OTX MES, you can also register a static IP address immediately with a mask which also suits your needs. Let's move on to the configuration of voice VLAN functionality, which is essential for dynamically allocating voice IP client traffic to a configured VLAN. On OTX MES switches, this configuration is flexible and can be done in several steps, as you can see. Thanks to dynamic routing, dynamic traffic allocation based on the OUI complaints table, you can work with voice equipment from any vendor. On OTX MES switches, voice VLAN configuration can be done from two sides, from the Ethernet switch side and from the side of voice equipment. Let's consider the first side from MES. First of all, we need to create the dynamic VLAN assignment according to the OUI table and designate the first 3 bytes of the voice equipment. With this next command, we define the voice VLAN ID into which the voice traffic will be dynamically assigned. It is also necessary to enable the feature of a dynamic allocating of the traffic based on the OUI table. In the interface configuration mode, we just need to write down the command voice VLAN enable, and the configuration from the switch side is done. In order for the voice equipment to assign traffic to a specific VLAN, you need to configure LODP MAT network policy. The initiator of receiving the voice VLAN, in this case, is the voice IP equipment. On OTX MES switches in global configuration mode, we should create the policy, specify its number, the voice LAN ID, and the type of the traffic. In our case, it's tag type. Then we are moving to the interface configuration mode and just bind our policy to this interface. I would like to point out that the CDP protocol is a Cisco proprietary and is not supported on OTX MES switches. However, if the phone only supports CDP, and not ODP. For dynamically allocating traffic to a specific VLAN, you can use the map MAC functionality, which is supported by MES. This will create a database of MAC addresses for phones that need to be assigned to a particular VLAN. Let's now move on to the next section of our comparative analysis. This section will focus on configuring the features for client ports. Specifically, we will discuss, for example, storm control, port security, IPv4 ACLs, DHCP group, loopback detection, and finally, dynamic ARP inspection and IP source guard. Let's start with the storm control. In this case, there are some differences in common syntax between Cisco and OTEX MES. Regarding the MES configuration, the storm control functionality applies to 3 types of BOM traffic: broadcast, unknown unicast, and multicast. The maximum speed can be specified in packets per second, kilobits per second, or in a level. However, with the first command air disable recovery with the core storm control, we are identifying the reason why the link should be automatically restored. It's advisable. According to how the system reacts to exceeding the specified speed, on OTEX MES it sends a lock and SNMP trap, or turning the port to the shutdown state. Also, these 2 reactions can be used simultaneously. Based on our troubleshooting experience, we recommend enabling the storm control functionality for all types of traffic. The configuration of the loopback detection functionality on the Cisco and OTEX is slightly different in terms of syntax and command sets. On the OTEX MES side, it is necessary not to only enable the functionality on the interface, but also in the global configuration mode. And also, we should specify the mode of the loopback detection functionality and the interval of sending the loopback detection frames. For OTEX MES23xx switches, you can choose the destination MAC address based on the source MAC address, multicast or broadcast MAC address, or the base MAC address, when the switch's own MAC address will be used as the destination MAC address. It is also recommended to turn on the air disable recovery with the cause of the loopback detection in the global configuration mode. And as the part of the interface configuration mode, we just need to turn feature on with the command loopback detection enable. Also, on this diagram that you can see, it is shown the 3 most popular loopback detection trigger scenarios. The first one is when the loop is formed on a device that is connected to the switch. The second is when the loop is formed within one device, but the functionality is configured only one interface. And the third is when the loop is also formed within one device, but the functionality, the loopback detection, is configured on the 2 interfaces. Let's move into the port security. The syntax of the modes may differ, but I will give you an example of how to configure a mode which acts similar to Cisco sticky port security mode. On OTEX MES switches, this mode is called Secure Permanent. In this mode, a limited number of MAC addresses are pre-configured and saved to the configuration. You can also set the maximum number of MAC addresses that can be learned behind the port and choose the violation type when a packet arrives from an unknown MAC address. In our case, it's discarding the packet and all the traffic that will come from the unknown MAC address. And with the last command, we just turn on the feature on the interface. Let's move on to the next feature, extended access lists. This slide shows 2 similar examples of how to configure the same rules on Cisco and MES switches. Within this feature, you may notice that there are minimal differences in syntax. For example, creating ACL is the same, just with the name, but creating a rule, you do not need to specify a host option on OTEX MES switches. Instead, you should use a wildcard mask where 0 sets the bit and, for example, in our case, 255 allow is a deny any. This rule is applied not at the end of each ACL, but after the all IP ACLs has been proceeded. In this first example that we have discussed, we should just add the rule permit IP any to let the traffic go through the interface. Additionally, let's consider an example of a management ACL configuration based on the example that you can see that differences are not just as big as you think they can be. If you look more closely at the second example, SSH permit V20, we can see that within the OTAX MES switch, access to the switch can be controlled not only by physical interface, by IP address or service, but also by a specific VLAN. Let's move into the functionality of the DHCP group. We will start with the DHCP relay, which transfers DHCP packets from clients to servers and back when the DHCP server and the client are in different networks. The configuration on OTAX and Cisco are similar in this case. In global configuration mode, we just turn on the feature. We are specifying the IP address of the DHCP server. And in the client VLAN configuration, we're turning on the work of the DHCP relay option. And for example, in this case, we are assigning the IP address in the VLAN where the DHCP server is connected from the subnet of the DHCP server. The DHCP snooping feature, designed to prevent spoofing of DHCP servers, is configured in the same way on the Cisco and OTAX. In the global configuration mode, we enable the feature and we define the VLAN in which we will allow control of the DHCP protocol. Next, within the physical interface, we configure the port to be trusted, which allows us to designate the port as the trusted port to which the real DHCP server will be connected and verification will not be required. The dynamic ARP inspection feature, which protects against MAC and IP addresses spoofing in ARP packets coming from the client, works based on the DHCP snooping compliance table. In this case, the configuration for MES is slightly different than for the Cisco. Additionally, it is necessary to enable this feature in the global configuration mode and not just in a specific VLAN as on Cisco. After that, we switch to the interface configuration mode and define the port as trusted using the IP ARP inspection trust command. The IP source guard functionality, which protects against IP addresses spoofing in IP traffic coming from the client, works based on the DHCP snooping compliance table as well. In the case of OTAX switch, we must add a command in a global configuration mode and on the required interface. I'd like to draw your attention that these settings should be used in addition to the previously discussed DHCP snooping features. Let's move on to our final section of our comparative analysis of Cisco and OTAX MES switch configurations. In this section, we will examine the configuration of OSPF and VRRP and discuss the allocation of routing table resources in the OTAX MES 23rd line switches. Let's start by configuring OSPF. As you can see, the common syntax for the OSPF is identical. To configure OSPF, first of all, in VLAN 10, we need to set the IP address first. Then we switch to the OSPF configuration for the process and specify the router ID. In this example, we use the same IP address that we have configured before, but this is not a strict requirement. By default, OSPF uses the oldest loopback address as the router ID if there are no other options. If there are multiple loopback addresses, the most senior one will be used. Next, we define the OSPF network where the OSPF will take place and the area in which it will operate. In our case, it's backbone area, and as you can see, a little difference in syntax, yes, we have. And then, with the final command, we indicate the routes that OSPF process can announce. let's discuss the configuration of the virtual router redundancy protocol, which is used to ensure that routes act as the default gateway in case of failure. For switches in the OTEX MES Ethernet switches line, you need to specify the IP address, which will initiate the VRRP process in the desired VLAN interface. Then you create the VRRP instance and assign it an IP address. Next, we should specify the priority of the VRRP router and enable the preemption mode to ensure that the backup router with high priority will take over the role of the master router in case of failure. And finally, with the last command, we enable the VRRP protocol for a specific interface using this command no VRRP shutdown. Let's take a closer look at the resource allocation in the route table using the OTEX MES23xx switch as an example. Based on its technical specifications, the switch has more than 3,500 layer 3 multicast IPv4 and more than 1,000 layer 3 IPv6 multicast routes, as well as more than 12,500 layer 3 unicast IPv4 and more than 3,000 layer 3 unicast IPv6 routes. It is important to note that both IPv4 and IPv6 unicast and multicast routes share general common hardware resources, which could potentially lead to the need for resource reallocation. This slide provides an example of output from a command that shows information about the individual allocation and usage of routing table resources. This part. In this table, the number of routes column indicates the total number of routes on the device. The number of neighbors column shows the number of ARP and tries, and the number of interfaces column represents the number of created IP interfaces. By default, 512 IPv4 entries are reserved, of which 1 entry is for the number of routes, 1 entry is for the number of neighbors, and 4 entries for the number of interfaces. Additionally, 2 route entries are reserved for each IPv4 address configured with the manually created mask and with the subnet mask /32. Let's now move to the IPv6 entries. In total, there are 256 entries available. Additionally, 64 entries are available for IPv4 and IPv6 multicast. If you need to redistribute system resources because, for example, IPv6 is not in use and it is need to use all available hardware resources for IPv4, you can use the command shown on the slide, this command. Using prompts with a question mark, it's easy to do, so as the minimum and maximum system resource values are specified. And I would like to draw your attention that after entering the command, this command, and pressing enter, the device will be rebooted automatically to apply the changes that you have configured. So before executing the resource allocation command, it is advisable to save the startup configuration first. So we have completed the main part of the webinar, during which I showed the configuration differences between Cisco switches and the OTEX MES23 line models. Now we can move on to answering your questions about the functionality that we have discussed. So as I see, our moderators give some answers. So I think the first question is .1x authorization supported? Are you working with Cisco OSPF? Yes, .1x authorization is supported both via the EAP protocol and MAC authorization with radius attributes, for example, dynamic SAL and VLANs. And according to the Cisco OSPF, yes, you can create a ticket on the service desk platform to our technical support team, and we will recommend you on setting up the profiles. So, okay, next question. Do you have VPC for backup in the IP fabric? It's a very interesting question. For now, we have the EVPN multi-homing for this feature because we have decided, our developers have decided that it will be more clearly and it will allow you to reserve the equipment not only with the 2 links, but for example, more than 2. In our testing lab, we have tested with, for example, 8 and more. About the stack support, I would like to come back to the slide and say about in more detail. Okay, about the stack support. On this line, we are working on it, and it will be available approximately by the end of the 2024. On this, at least equipment, the stack is supported up to 8 units in a stack. And for example, for this line, we have supported the non-stop forwarding when the backup router and, for example, master router failed, and the backup router will immediately take place of the master. And for the industrial switches, as I remember, we support stack, but not for 8 devices in a stack, by 3, I think. Regarding the question, we have attacks with new software and we have a recent disconnect via putty. Can we extend it this time on old LTEX software? We don't have this problem via putty remote. I think this question, we should discuss this question. Can you please create the ticket on the service desk platform? And our technical specialists will help you because, for example, we need some diagnostics to solve this problem. Can I do all these configurations through the web? By now, of course, you can configure through the web, but not the all functionality. If you have some questions, also you can write in the service desk, and we will discuss this question. How to connect LTEX to ICS Cisco? Please write in our technical support on the platform service desk, and we will give you an example of how to create the profile that will suit our MES. Because, for example, as you can see, we have several types of our product lines, and from the line to line, maybe some differences may take place. Again, regarding the units, 8 units. For equipment, for most of the equipment, 8 units. For industrial switches, 3. Are there some questions that I have not answered? Let me take a look. So, okay, I think all questions are answered. And I would like to say that thanks for attending the webinar. We'll be waiting for you at our next webinars. Have a nice day.